matter is everything, as long as it has a mass and a volume. And we can categorize matter into two. The first one is a substance, and the second one is a mixture. A substance can be categorized as an element and a compound. And so, an element is a substance no matter the quantity. It will be considered an element as long as each and every single one of the atoms are the same. So a very common element that we know that you might have heard of is oxygen. And as long as we have, it doesn't matter if we have this much oxygen or this much oxygen, that substance is considered as an element. And a compound is two or more different elements combined chemically together. Now, a compound, it can be, an example of a compound is water. This is the formula for water. And as you can see, the H is an element called hydrogen. The O is oxygen. So hydrogen and oxygen are chemically combined to form this water, which is a compound. Now, you may have heard of the word molecule, and to not get confused between what a molecule is and a compound refers to two or more elements. So this refers to two or more elements. Molecules refer to as two or more atoms. They're both chemically bonded to each other, but a molecule can be this, which is also a compound, or it could be the same element bonded to itself. So O2, which is two oxygens together, is the most common form of oxygen as a gas that we breathe in every day. And this is counted as a molecule, but it is not a compound because it is only one element. Okay, now let's move on to mixtures. So mixtures, there are two types. There are heterogeneous and there are homogeneous. And so, let's start off with heterogeneous. Heterogeneous mixtures are usually, let's start off with mixtures first. Mixtures are two or more substances physically combined. So maybe two or more. Okay, physically combined. And a heterogeneous mixture is a mixture that is not uniformly has a composition throughout the whole mixture. And so, an example of a heterogeneous mixture, let's say for example this pen and this towel. These two are substances. They are forms of matter, has a mass and a volume. And if I physically combine them like this, I'll physically combine the mixture, the substances into a mixture. There you go. It's a mixture now. And one really easy way to determine if it's heterogeneous is that you can see both of the components of the mixture. You can see there's the pen and here's the towel. Also, if you look throughout the whole mixture, it's not a uniform composition throughout the whole mixture. That's what makes a mixture heterogeneous. Now, for a mixture to be homogeneous, it must have a uniform composition throughout the whole mixture. And I'll give you an example. Here I have a glass, and I'm going to fill it up with a substance, water. Okay, so I filled it up with water, and here I have some toothpaste. Just so you can see, remember that we could see both of the components of the last mixture, which made it heterogeneous. See, now let's look at this mixture. You can clearly see the toothpaste. Okay, so right now, that's how it is. Let us physically mix them. Hopefully the toothpaste can be dissolved in water. Alright, now that I have physically mixed both of the substances, let's see. Okay, can't really see in it, it's very foggy. And remember, a mixture, a homogeneous mixture, has to have a uniform composition or consistent composition throughout the whole mixture. So let's see if it has a consistent composition. It should all be the same way throughout. So I'm gonna pour it. Okay, that was really consistent, but I guess I didn't dissolve all of the toothpaste. Ignoring this toothpaste inside, I would say that that mixture that we had was a homogeneous mixture. So now we have seen the different kinds of matter. There were elements, there were substances, there were compounds, there were mixtures, heterogeneous and homogeneous. And now we know what each of those are. And another thing with mixture that I would like to talk about are solutes and solvents. These are two words that are very easy to get confused with also. And an easy way to, well, first of all, in that last example with the water and the toothpaste, the solvent was the water. The solute was the toothpaste. How did I know that? So, an easy way to tell, what I use, a very easy little trick is, solvent, it has 7 letters. And solute, it has 6 letters. So you know what? The bigger one, the solvent, is the water. Here's the cup. Here's the water. Here's the toothpaste. The bigger part is the solvent that is doing the dissolving. And the solute is the smaller part that is being dissolved. I just wanted to clear that up.